video is about types of forces in Newtonian mechanics. Question number 1. What is the meaning and equation of directly proportional, inversely proportional? Give an example of each. So directly proportional means as x increases, y increases, and as x decreases, y decreases. So an example would be the more money I have, the more friends I have. Also, the less money I have, the less friends I have. So an equation for that would be y equals kx, where k is a non-zero positive constant. Inversely proportional means as x increases, y decreases. So y decreases, x increases. So the more I study, the less my parents will hate me. The less I study, the more my parents will hate me. So an equation for this is y equals k over x, where k is a non-zero positive constant. So for directly proportional, if x gets bigger, y gets bigger. If x gets smaller, y gets smaller. For inversely proportional, if x gets bigger, y gets smaller. If x gets smaller, y gets bigger. Question number 2. What is mass? What are its units? Is it a scalar or a vector? Mass tells us about the amount of matter in an object. So more mass, more matter. More matter, more mass. The units of mass is kilograms. It's a scalar. There's no direction for mass. Question number 3. What is a force? What are its units? Is it a scalar or a vector? How many objects are needed for a force? A force is a push or a pull. The units of force is newtons. Force is a vector. We need at least 2 objects for a force. For example, I push the wall pushes me. I pull on the box pulls on me. Question number 4. What is a force of gravity? This is also called weight. In which direction does it point? 2 objects with mass are attracted to each other. The force of gravity pulls the 2 objects towards each other. The force of gravity is always an attractive force. Mass attracts mass. So if we're near the surface of the Earth, the force of gravity always points towards the center of the Earth. Question number 3. What are the equations for the force of gravity? If we're near the surface of a planet, force of gravity is mg, where little g is 9.81 meters over second squared down. M is the mass of an object. So if you jump, according to this image, the Earth pulls you down and you pull the Earth up. Part B, in general, the general equation for the force of gravity is g m1 m2 over r squared, where g is a constant, m1 and m2 are the masses of object 1 and 2, and r is the distance between the 2 centers. Question number 6. What are some differences between mass and weight? This is an important question because some people ask you, what's your weight? How much do you weigh? They should ask you, what's your mass? Mass is a scalar, weight is a vector. Mass requires 1 object, while weight requires 2 objects. The units of mass are kilograms, while the units of weight is newtons. So don't confuse the two. Question number 7. What is a normal force? The normal force is the force a surface gives to an object. The normal force always points perpendicular to the surface. So look at the image on the left. You have a box on the ground. The force of gravity pulls the box down. The normal force pushes the box up 90 degrees from the surface. Take a look at the image on the right. The force of gravity pulls the box down. The normal force pushes the box up from the surface, 90 degrees from the surface. Question number 8. What is the force of friction and in which direction does it point? Draw an image. The force of friction usually points opposite to the direction of motion. So there's a special situation where an object M1 is on top of a moving object M2, which makes M1 move. Examples of friction are surface friction, air friction, and a viscous drag force of on an object falling in a liquid. So look at this image. Imagine force of pull is to the left. Something is pulling this object to the left or pushing it to the left. The force of friction is going to be to the right. Question number 9. What is the equation for surface friction? Define each variable. Force of friction equals mu times force normal. So mu is a coefficient of friction. It has no units and it's always greater than or equal to 0. If mu is big, then there's a lot of friction. If mu is small, then there's not a lot of friction. Question number 10. What is the meaning of dynamic or kinetic? What's the meaning of static? Which is greater? Kinetic friction or static friction? Kinetic means moving, static means not moving. So static friction is greater than kinetic friction. So mu static is greater than mu dynamic. So remember this. Force of friction is equal to mu times force normal. Question 11. What is the meaning of a rough surface, a smooth surface? In a rough surface, we have surface friction. Mu is greater than 0. On a smooth surface, we have no surface friction. Mu is 0. Question 12. For which object do we observe the force of tension? Draw an image. These are strings, usually massless strings. So you can see the force of tension is in the same direction as that string. It's holding the object up. Question number 13. What is the equation for the spring force? What is the name and what are the units of K in the spring force equation? So imagine you have a spring with the mass attached to the spring. It's at the equilibrium position, x equals 0. That means it's not moving. You pull the mass to the left. When you let it go, the force of the spring is to the left, the force of friction is to the right, the normal force is up, the force of gravity is down. Force on the spring is minus k delta x, where delta x is the distance from the equilibrium position, or the displacement from the equilibrium position. Force of the spring is called the spring force. K is a spring constant. So if K is big, then the spring is stiff. It's difficult to get that spring to compress. If K is small, then it's very easy to compress the spring. This negative sign is called the restoring force, and it returns the mass on the spring to the equilibrium position. So if there's no friction, you release this object, it just goes left and right forever. Question 14. Draw a force versus displacement graph for a mass on a spring. What does the slope of a force versus displacement graph tell us? What does the area under force versus displacement graph tell us? So look at this equation. F equals minus k delta x. Let's graph this. Delta x is on the horizontal, force spring is on the vertical. Ta-da! The slope has units of newtons per meter. The slope tells us the amount of force needed to achieve a certain displacement. It tells us about the stiffness of the spring. So as we pull the mass from the equilibrium position more, we could determine the force needed to pull that. Mass from the spring. Mass from the equilibrium position. The area has units of newtons times meter. These are units of energy and work. So the area under the curve tells us the work done on the mass by the spring. Question 15. What is a buoyant force? State its equation and define each variable. Pressure from a fluid increases with depth. There is an unbalanced force which points upward. For buoyant force is rho Vg. Rho is the density of the fluid, V is the volume of the fluid displaced, G is the acceleration from gravity. So if we have this dead fish in radioactive water, buoyant force points up, force of gravity points down. Question 16. State the equation for the viscous drag force acting on a small sphere opposing its motion through a fluid. Define each variable. So the equation is force of drag equals 6 pi nRV. Eta is the fluid viscosity, depends on the fluid. The more thick the fluid is, the greater fluid viscosity is. R is the radius of the sphere, V is the velocity of the sphere through the fluid. So the Greek letter eta looks like the N. And this is what we have here. Imagine the sphere moving down. The force of gravity is down. Buoyant force is up. Force of drag is up.